Pause and copy. Okay, so we have a semicircle surmounting a rectangle. The picture I get is this one. Zoom in a bit for you here. So copy that in. Now, we want to maximize area. So area. And what's the other thing? Perimeter, fixed perimeter. Okay, so there's our two equations. So area will be the easier one, I think. Area is the semicircle. So semicircle plus rectangle. So that's half of a circle. So pi r squared over 2 for that guy, plus the rectangle, which is 2ry. Perimeter is 18. Perimeter is a bit trickier. We have to remember the circumference of a circle. So a circumference of a circle is pi times diameter. We want half the circumference. So we want c over 2, which is pi times d over 2. And d over 2, the diameter is, well, there's the diameter. So d over 2 is just r. Okay, so what have we found? We have found that this semicircular edge has length pi r. So we got pi r plus 2 side lengths of length y, and then 1 side length of length 2r. Okay, so I'm going to be taking this guy and plugging it into the area equation. So I got to choose, do I want to solve for r or do I want to solve for y? In principle it doesn't matter, but I'm going to be squaring this r, right? So maybe I don't want to do that. So if I don't want to do that, I should solve for y here. So here I get 18 minus pi r minus 2r is 2y. Dividing by 2 gives me 9 minus pi r over 2 minus just r. And there's my y. Bringing my area equation back, pi r squared over 2 plus 2r, and then the thing I found is going in for y. Okay, so I'm going to spend some time simplifying this. Start by expanding. So this is time well spent, I believe. 18r minus 2 cancels with 2, giving me pi r squared minus 2r squared. Like terms. I have this guy, and this guy. These are all r squared terms. So I get pi over 2 minus pi minus 2 times r squared. And then the 18r can sit on the end there. It may seem tedious, but it's good to simplify before you do calculus, because your derivatives can explode on you And nobody likes exploding derivatives. Okay, what do you think? Now I will do a derivative. A prime is, well, this 2 comes down. I'll put it out front there. Plus 18. Don't like this denominator, so I'll multiply this 2 into the bracket. Minus pi minus 4 over r times r rather, plus 18. And we're setting this equal to 0 to find the maximum area. So let's bring the bracket over. We get pi plus 4. R is 18. R is 18 over pi plus 4. So the question asked us to find a radius, and we did. So I'm pretty sure we're on the right track. To double check, we do a little number line with our simplified derivative. Let's take here. Here we have a prime. And we're going to put our critical number on there. It's a little bit tricky, but I think the best idea is to not get too fancy. Pick a number over here, pick something easy. 0. Plug in 0 into my derivative, you get plus 18. So increasing. Now if you pick, what is this? 18 pi plus 4. What is this roughly? This is roughly, 18 over 7. Whatever that is, certainly smaller than 18 over 6, right? Which is, so I can choose the number 3. So I can be sure that 3 is over here. Or you just choose a humongous number for r. Throw that big number in here. Throw that big number in here. You get a very large negative number, plus 18, giving you negative. So we do have a max here. And it is the max we're looking for.